A quick message before we start to say that we are only 2 weeks away from 150 episodes. I would absolutely love to hear what you've learned about the universe or your place in it from listening to Pale Blue Pod. So please send your lessons learned to palebluepodcast@gmail.com or message us on Instagram @palebluepod, and maybe you'll hear your lesson on our special 150th episode. But first, episode 148. Hello, and welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend. I'm your host. I'm Dr. Moiya McTier, an astrophysicist, a folklorist, and a friend to the universe. Today, I'm recording from my office at Pale Blue Podiversity. I'm expecting a guest. Dr. Deboki Chakravarti got her PhD in biomedical engineering, and now she's a science writer and co-host of Tiny Matters, another show on Multitude. I just heard her horse and buggy outside the building, so she should be here any minute now. Hi, Deboki. Welcome. Come on in.
Hello. I'm so excited to be here. Thanks for the patience with my buggy. It got a little stuck there for a bit, but, you know, it happens.
Oh, of course. You know, we care so much about the horses here. We're just working on their schedules.
Yes, yeah.
Is there anything else you would want people to know about you before we get into the episode?
No, mostly it's just Tiny Matters. I exist in Tiny Matters, and then when Tiny Matters is not going, I stop existing.
You're right. You poof into a non-corporeal form.
Exactly. I'm Schrodinger's podcast host.
Oh, great. It's except instead of a box, it's a little recording closet.
Exactly.
Love that. Okay, well, I do have some get-to-know-you questions, so I can know you a little bit better, and so can the listeners. The first question is the most intense, perhaps. When you think about the vast universe out there, how do you feel?
Oh, my God. I mean, definitely overwhelmed. It's so weird because it's also scale-ish dependent. Sometimes I'm more overwhelmed by the small things than the big things because I think the universe exceeds what I can comprehend. That I almost can't get to the point of being as overwhelmed as I am when I think about ecology. Ecology freaks me out because I'm just there's so many things happening to make life possible. And that's also true on the universe scale, but it's to a degree that I just cannot wrap my head around. So it's overwhelmed in a different way.
Oh my God, yes. Yes, I'm so glad you brought up the small scale thing because I agree. I think that's scarier. There's one universe. There are billions of germs around me. Right. What do you mean? Those are so much scarier.
Yeah. Do you know how many ecosystems there are on one planet? I don't know, but it's a lot of them.
Okay. I think we're in agreement there. That's awesome.
Yeah.
Do you feel like your sun sign fits who you are as a person, your astrology sign?
Yeah. So I'm a Libra. And I think so. So Libras are about balance. I think that's our main thing. Constantly unable to make a decision. Totally me. Because I'm just I gotta know all sides of a thing. I need to know. And then I think we're also supposed to be really obsessed with pretty things, which sounds right to me. Put a pretty bauble in front of me and yeah, I'll be distracted.
You're basically a crow.
Yeah, exactly. Yes. Anything that I've read about Libras, I don't think there's anything that's come up that I've been no, that is not me. That is absolutely not me. Most things that I've read, the indecisiveness, but also the fairness and the openness to aesthetics and everything. I'm yeah, I think that sounds right.
Mm-hmm. Do you read horoscopes or anything since you feel it really matches you?
I check in and out because I feel with astrology itself, I try not to believe too hard in it, partly because I don't really know what to do with that belief. I feel it would rule my life in a way that I'm not necessarily constantly wanting for myself. But I do like checking in with my horoscope more when I'm in a place of I feel like the universe feels vast and unknowable right now. And I don't think this horoscope is going to help me know the universe better, but I think it's going to help give me like something to focus on. Like I like the horoscopes that are not like, oh, this thing is going to happen to you today. They're more like, here's some things that might be going on and here are some ways to think about it. And that's like what I find helpful, because otherwise, you know, I can churn for a while in my brain, but it's kind of nice to have some like outside voice being like, here's an approach. And I'm like, okay, cool. I don't know like how much I like think that actually fully applies to me, but it gives me something to start with.
Yeah, it's a good lens, a good starting point. And that type of balanced approach does seem very Libra of you.
Yes, yeah. Yeah, I will never say outright whether or not I believe in astrology or not, but I will engage fully with both ideas of like, I do and I don't.
Love that. And happy almost birthday.
Oh, thank you. Yes, it's coming up.
Yay. Okay, next question. If you could change any law of nature, what law and like how would you amend it?
My first thought was gravity. Like, screw gravity. Who needs that?
Get rid of it?
But we probably all need it.
Just a little.
But I'm still going to, you know what? I'm going to go big. I'm going to say, let's get rid of gravity. Like, let's see what happens. We don't need the universe to be held together. We don't need things to cohere. We can just be floating. Like, things don't need to be drawn to other things. Let's just see what happens when gravity's gone.
Deboki woke up this morning and chose chaos.
Yes.
She chose to rip the universe apart. You're on the side of dark energy.
Exactly. Yes. That is where I'm coming from. A place of dark energy. Watch everything just like disintegrate. And like it's funny because it's like the reason gravity is my enemy is just because like I'm clumsy, right? Like I'm like, I'm falling. Gravity. I don't like it. But like gravity does so much more that I gotta like appreciate. But no, I'm not gonna give it to gravity.
Oh, might I suggest an amendment to your amendment then?
Yes.
What if gravity acts, it already does, but what if gravity acts much less strongly on less massive objects? Because your clumsiness is for like you and things that you drop, which don't weigh that much.
Right.
So if the light objects didn't have to experience gravity that much, the planet could still hold together.
Yeah, see, this is why I need physicists in my life, because I'm just like, binary, gravity exists or it doesn't exist. I forget that like there's this whole like world of thought exercises where it's like you don't have to completely get rid of it. Like you could like experiment with like a little bit less gravity in this area, or like something that's just a little bit switched that makes it okay for you but also keeps the universe together.
No, but I like it. You're just like, we can start a new one with new rules. It's fine.
Yeah. Who invented gravity anyway? We don't know, right?
We don't know her. We just don't need it.
Yeah.
I read on your site that as a science writer, you have learned a lot of different animal facts in different contexts. I'm wondering if you have a favorite space animal fact.
A space animal fact? I mean, the go-to has to be that we've like sent tardigrades to space.
Like intentionally?
Yeah, I'm pretty sure we sent them to space and they might have crash landed on the moon. And I can't remember if they survived. I'm pretty sure we've sent tardigrades to space to like see like, can they survive probably like the radiation, I'm guessing, and stuff. And I don't know what happened to them. Like, are there tardigrades floating around Earth now? Maybe. Are they surviving?
Right. They can survive so much.
Yeah, they really can.
Nice. My favorite animal in space fact is that we have tried to have so many animals, except for humans, reproduce in space, like sexually reproduce. And my favorite example is this group of cockroaches where they sent up a cockroach to, I can't remember if she was already pregnant when she went up there, but she gave birth to many cockroaches, and then they came back and they were a different color than they normally are. Like normally the cockroaches are brown, and they came back and they had like red bellies, and so
that's amazing.
Space makes a difference. Yeah.
Oh, that's so cool. I'm going to look this up later. I'm so curious now about all the other animals that we've tried to get to reproduce in space. That's amazing.
Yeah, like we will really try to make anything have sex in space except us.
Which is like, it is wild that we haven't gotten humans to do it for science and space, right? Like,
because people would volunteer. You wouldn't have to force.
But the ethics, like, it's really hard to do science, obviously, with, like, pregnant people. Like, this is, like, part of why pregnancy is such a black box. It's, like, for a lot of reasons, some of which are just, like, standard patriarchy. But also, like, it's hard to ethically do experiments that involve, and, like, clinical trials that involve pregnant people. And this would be, like, the most. Like, the thing that there's, like, nothing else to really go on.
But even before that, I think that, like, we don't have a good idea of how circulatory systems would work, or just like the mechanics of sex in space, not totally clear. People have made suits that basically like Velcro you together so you don't like bounce each other apart. But there's a dearth of knowledge there for sure.
For sure, yeah. Bodies, so weird. It's so weird. Like, that's another thing that like overwhelms me. It's like the fact that, like, we live on the planet that makes it possible for our bodies to exist the way that they are. And, like, that is a function of also the planet being the way it is. Like, it's not like we have this body, this Earth existed, they found each other. It's just this Earth existed, and our body is, like, developed over a very long period of time, like, evolved over a long period of time in response to it. And that's just crazy. Like, life is crazy.
Sometimes when I, like, have nothing else to do, I sit there and I think about, like, really how crazy it is that we are here and how just, like, super fine-tuned we are to this particular chunk of rock in space.
Yeah. My husband makes fun of me because when I started working on this show a while ago that's now over called Journey to the Microcosmos, and it was all about microbes and, like, just, like, exploring, like, the tiny little universes around us. And it was my first time really, like, kind of diving into biology at, like, such a small scale. Well, like, I came from biomedical engineering, but I wasn't really thinking about, like, ecology and stuff like that. And I would, like, come out of each of these scripts just being like, I'm so overwhelmed by the world right now. Like, I just cannot process that all of this has been going on.
Yeah, it's too much to take in.
Yeah.
I agree.
Yeah.
All right, and maybe a lighter question now.
Yeah.
And the final one. Imagine you're an astronaut. You are strapped into the seat. You're about to launch, but you're in charge of the playlist. So what song do you want to play during blastoff?
You set up that image, and all I was thinking is, like, I'm going to spend the whole time thinking, like, I gotta poop. I gotta poop. I gotta pee. I gotta poop. I can't be in charge of a playlist.
I can't control a playlist. I'm busy controlling my bowels.
I know, yeah. You set this up as a lighter question, and I took this immediately into a darker place in my head, which is, what if something goes wrong and this is the last song I ever hear?
Oh no. Yeah, that's one way to think about it.
Yeah. There's a lot of reasons that I would never be an astronaut, but the overwhelming anxiety and fear that I have for the most mundane tasks and the fact that I, like, don't think I could handle it is probably the biggest one. I mean, I'm such, like, a boring Swiftie, so it probably would end up being a Taylor Swift song, which would probably drive other people crazy, like, if other people are not as, like, into that. The other thing I was thinking about is the playlist that we put together for when I went into labor, and I'm, like, just thinking about the absolute bonkers range of music we had. Like, we had, like, 80s power ballads. Of course, we had Taylor Swift, like Florence the Machine. It was, like, a range of stuff. And I feel like I might just bring that playlist. Like, because I think it covered a lot of moods. Like, it was motivating. It was soothing. It was enraging. It covered it all. And I think that matches the mood of, like, jetting myself into space.
Yeah. So is there a song?
Oh, right. A particular song.
That you think,
okay, so the song that I was thinking of is a song called She's Enough by Atmosphere.
So appropriate.
Yeah, yeah. Which is really just about a wife guy talking about how awesome his wife is, which is why it was on the playlist. But that's the energy I would need to get myself into space. That would be like, you can do it. You can do it. I swear you can do it. Like, you're enough. You got it. So, and it's funny too. So it would, like, probably take my mind off the scary thing that I've, like, gotten myself into. I think that would be the song.
Hell yeah, dude. Yeah, that's great. That's a good one. Was Push It by Salt and Peppa on the playlist?
I don't think so, but I know like definitely other people do it. Like I remember being in conversations with people talking about putting it on their playlist. Yeah, that was one.
I love that idea.
There's this like great power ballad that would always come up on the radio here called Warrior. That was like so 80s, right? It's like, I am the warrior. And I
love that song.
Yeah, it's great, right? So that's like, if that came up on the playlist, it would be perfect, right? It's gonna like pump you up to get you into space. I mean, there's all the like good space songs, which like I feel like I should be playing, but I think you're going to be in space anyway.
Yeah, that brings enough of the space theme that you don't also have to listen to music about it. Yeah. That's a good choice.
Thank you.
Nice. Okay, so today we are doing another This Week in Astronomy History, and we're covering the week from September 29th to October 5th. I chose to start this week on the Monday instead of the Sunday because October 5th was just too exciting.
So this is funny because September 28th is my birthday, but it's fair. That's fine.
Oh, I just missed it.
Just missed it. That's okay. It's fair. If October 5th is the good day, let's do it.
Okay, so then happy late birthday by the time this episode comes out.
Exactly.
I'm going to go through each of the days and tell you some exciting things that happened on that day in history, starting with September 29th in 1951. This is the day that Seth Barnes Nicholson discovered the 12th moon of Jupiter. It was originally just called Jupiter 12, and then once naming conventions for Jupiter's moons were updated in like the 2000s, we named it Ananke, and that is a figure from Greek mythology, and all of Jupiter's moons are named after figures from mythology that he either had affairs with, or his offspring, or just like people he interacted with in mythology stories. The moon itself is the largest moon of the Ananke group. They take these moons, there are almost 100 moons of Jupiter, and they split them up into different groups based on where they think they originated and the shape of their orbit. And there are 16 members to the Ananke group that we think originated from the same asteroid that was captured by Jupiter's gravity and then broken up through some collision. It's about 50 miles across. It orbits 23 million miles away from Jupiter.
Can I ask, like, how do you go about discovering a moon?
Great question. Yeah. This one, it got its name in 1975, the Ananke name, but it was discovered in 1951. So back then, it was probably just like they took an image of it. We were still studying basic enough stuff about the planets that you could just see it through a telescope.
Cool.
Just like Galileo did with the Galilean moons.
Yeah. Is there any chance that like it's the kind of thing someone might have observed like a long time before and not realized what they were saying? Or is it like something that would be like so rare / hard to observe that like it would be likely to just be kind of uncommon?
Not rare, but unlikely just because it's so small.
Got it. That makes a lot of sense.
It's really small, and it orbits far away from Jupiter. It doesn't emit its own light. So without a powerful enough telescope, which they like got in the late 40s, early 50s, you wouldn't have been able to see it.
That totally makes sense. Cool. Thank you.
Yeah, of course. Thanks for asking. And then I want to talk about the myth that the moon is named after. I've been doing this series on TikTok called Cosmythology, where I talk about a moon and a myth figure that share the same name. And Ananke is really interesting because she's this primordial figure. She's a personification of necessity and fate. In some stories, she's a lover of Kronos, the Titan of time, and in others, a lover of Zeus. And she's considered the mother of the fates. So she is one of the few people who has more power than fate. And in that way, she might even be more powerful than Zeus. So I don't like this name for a moon, actually, especially not this moon. I think this moon is way too small and insignificant to be named after this figure from mythology.
Yeah. You got to swap it with Jupiter.
Yeah, exactly. Yes. Oh, that would be like the feminist turnover of the of the millennium.
That's amazing. What a myth. What a figure.
What a figure. I love her. Love Ananke. That's 1951. In 1988, on the same day in September 29th, the Space Shuttle program safely returned the Shuttle Discovery from its 26th mission, STS-26. It was the first shuttle mission after the Challenger explosion. So I imagine there was a lot of pressure on NASA to do everything right. And you can see that. It's the first all-veteran flight crew since Apollo 11 in '69. So every astronaut on that flight had flown in space before. Big change from Challenger, where there were teachers and like civilians who were caught up in the tragedy. They delayed the launch by 90 minutes because they were being super careful. They wanted to replace some fuses in the cooling systems for the astronaut suits. Two of them were malfunctioning. And there were also lighter winds in the upper atmosphere than they were expecting, and they didn't want that to affect their flight trajectory. So they waited over an hour and a half. They were being very careful. But they did launch, and they performed many scientific missions up in space. They put up a satellite, an infrared communications satellite, to like relay data in a geosynchronous orbit, which means it moves at the same rate that Earth rotates. So it's like doing one orbit every roughly 24 hours. But instead of being stuck over like New York City, for example, it will like move up and down to different latitudes.
That's so cool.
If it were staying over New York City, it would be called geostationary.
Okay. Got it. Wowee. Like just hearing about like the delays, like I'm always so amazed when I hear people talk about like anything launching into space where you're just like, people have to prep for so long to do these missions. And then it like all comes down to like a moment of just like, is it going to work? It's so amazing.
And something as seemingly small as like wind speed can make such a big difference.
Right.
I'm glad they were careful. And I think that the space shuttle program would have ended a lot earlier if this mission hadn't been as successful as it was.
Yeah, that's a lot to think about. That's heavy.
So on a lighter note, literally on a lighter note, in 1676 on September 30th, Danish astronomer Ole Romer announced evidence of the finite speed of light for the first time.
Oh, so cool. So how did he go about it? Like, what was his evidence for it?
Yes. He was in Paris and he was studying Io. This is one of the big Galilean moons of Jupiter. I think it's the closest Galilean moon to Jupiter, so it orbits pretty close. And that means it orbits fast. It takes about 1.75 days for Io to go around Jupiter, so we should be able to see it eclipsing Jupiter every 1.75 days.
Okay, like Earth days.
Yes. So we can see many of these Io eclipses per year.
Yeah.
And after many years of observations, Romer realized that his predictions for the timing of that eclipse were off. It could swing by about 20 minutes. So when the Earth and Jupiter were closer together, it seemed like the eclipses happened earlier than expected. When they were farther apart, it seemed like the eclipses happened later than expected by about 10 minutes. And he knew that nothing about the system itself was changing. Like Io isn't moving further or closer to Jupiter over time. So it must be something about our orientation between Earth and Jupiter. And he realized that it has to do with like the distance between us. And so he calculated that it takes time for light to travel across the solar system. And he measured that it should take about 22 minutes for light to cross the diameter of Earth's orbit, which is pretty darn close to it's 16.7 minutes.
Wow.
Like he was 5 minutes off.
Oh my God.
Before stopwatches.
And that's based off of looking at a moon.
Yes.
That's
that's based on looking at a moon like a billion miles away.
Yeah. That's so cool. And like, do you know like how was this contentious at the time? Like were people like, nah, like that can't be the thing that's happening. Like there's not like a finite speed to light.
People had been thinking about that before. I think Galileo had and his contemporaries were wondering about that. Because when you see light bending through a prism or through water, you can get the intuition that it doesn't always travel in a straight line, which means it has to travel at all. And so I don't think it was like the hugest splash, but it did take some time to get used to. And then over the next several decades, centuries, we got more and more accurate values. So the first, I'd say, accurate value for the speed of light was found in 1728 by James Bradley, and he measured it to be 301,000 kilometers per second. It's like 299,000.
Yeah.
Yeah.
Wow.
So
yeah.
close. Yay. So that was a lighter day in history.
Yeah, that's so cool to think about because, like, I don't know, there's always those science things that you kind of like take for granted. And I don't know if the speed of light is necessarily like a thing I take for granted, but it's definitely like a thing where I'm like, yes, that is what physics now, like, I remember having to plug C into a lot of equations in college. And
So many.
it's all over the place. Like, I don't think I ever thought about like, like, how did we first conceptualize the idea that there is a value for this, like that there is something here going on. And like you're saying, like, you know, it might not have been the most like rock your world kind of discovery, but I would imagine like having some sense of evidence like helps give the sense that we'll be able to uncover more. Like there is more to dig through here. We're going to be able to figure out something more accurate and something that's just like more ways to deal with this value.
Yeah, the late 1600s were a much better time than the late 1500s for astronomy. Yeah, Galileo did a lot.
Yeah.
Have you ever measured the speed of light yourself?
No, I haven't.
We used to run lab experiments when I was a grad student, and you can measure the speed of light with a chocolate bar and a microwave.
How?
So if you know what wavelength your microwave is using, which you can like find in the user manual.
Bold of you to think I have the user manual for my microwave.
You have Google.
Yeah. But does Google have the information anymore? Who can say?
If you go past all the AI crap.
Yeah. Sorry, go on. What's the experiment?
Right. So you take out the turntable so it doesn't spin, and you put the chocolate bar in the microwave. When you take it out, there will be two spots, or depending on how long the chocolate bar is, there will be multiple spots that are more melted than the others. Those are the spots where the microwave light passes through it. So you can measure that wavelength. You can measure the distance between them, and then you can like combine to work out the speed of light.
Oh, that's so neat. That is so cool. Waves are so weird.
They're so weird, and we know enough about how they work to use them to our advantage in so many contexts.
Yeah.
And then you have melty chocolate, get some strawberries, dip it in.
Exactly. Multitasking. You can't do that with a mountain.
Not unless you want to break your teeth. Still September 30th, but in 1880, Henry Draper took the first photo of the Orion Nebula.
Oh, cool.
On September 30th. Yeah. The Orion Nebula, a.k.a. Messier 42 or M42, is a star-forming region about 1,500 light years away from us in the constellation Orion. It's the closest star-forming region to us, so it's one of the most well-studied, and it's visible to the naked eye. Ancient cultures knew about it. To the Maya, they considered it the fires of creation, the source of the universe. To the Yolngu in Australia, it was the kingfish that three brothers fishing in a canoe caught, and then that made like the Orion belt part of the constellation. And so people have known about it for a long time.
Yeah.
And we only took the first photo of it in 1880. Cameras were invented in the early 1800s, and Henry Draper was an early adopter of them. He was an early astrophotographer, took the first picture of the moon in 1840, the first picture of a spectrum of the sun in 1872, and then this picture of the Orion Nebula in 1880 with an 11-inch telescope, 11 inches wide, not long. An 11-inch.
I appreciate that because I definitely was like, that's a tiny telescope.
Today it would be, yes.
Yeah.
But it's like this long tube with an 11-inch lens at the end of it. And he just had that telescope chilling at his estate.
Yeah.
Like he was a very wealthy man. And I've seen the pictures. No one would stop for them on Instagram today.
Yeah.
But they were state of the art back in 1880.
Yeah. Well, you know, it's the things that actually sometimes teach us the most are not always the most beautiful.
Exactly.
As much as that kills me to my Libra core.
I guess they could do some science with it. Like they could try and measure how bright it was. But since it was visible with the naked eye, like they could kind of already do those measurements. So really it was just about like getting people excited and interested.
That makes sense. Yeah. It's kind of like how like when the solar eclipse happens, like everyone's posting the same picture and it's like, okay, at this point, But the fact that everyone is excited and like taking a picture is actually still really cool. Like there is actually something really exciting about just everyone gathering and being like, oh, look at the thing in the sky.
Yeah. Although you can do real science with that. If you have people around the world, not around the world because solar eclipses can't be seen everywhere at once, but if you have people along the path of totality taking pictures at different times with accurate timestamps, you can measure accurately the duration of the eclipse. And if you get it from different observing locations, that can tell you about general relativity and like the way that gravity affects light. It was during a solar eclipse that in 1919 that Einstein's relativity was like proven for the first time.
Right. This sounds familiar. Oh, amazing. That's so cool.
Mm-hmm. So we had to do real science. Draper's pictures were not very useful scientifically, but
they were very cool still.
They're very cool.
Useful has a lot of different connotations. Like useful does not always have to mean that it taught us something like clear cut scientifically.
Exactly. Yes. And as a hardcore lover of Orion, I appreciate anything that brings attention to it. And I'm wondering if you have a favorite constellation.
A favorite constellation? Actually, I loved Orion growing up because I could spot Orion. Basically, any of the constellations that I could spot, I was like, that's a good one.
Relatable.
But the other day I was at a concert a few weeks ago that was outdoors, and like I could spot the Big Dipper and like some of those, but I couldn't find Orion, and I was really sad, and I kind of felt like I couldn't find a friend.
Oh.
Yeah.
Yeah, I think of Orion as a friend too. Yeah. I'm so happy when I can see him. I have him tattooed, so I can, even if he's not in the sky, I can always talk to him a little bit.
Yep.
Yeah. Hey there, friends. It's me. Deboki is looking through a compendium of otherworldly animals that she found on my shelf. We had a visiting lecturer at the Podiversity this semester who's an interstellar traveler, and I got this signed copy of their book after the seminar. So she's going to look through that for a little bit while I take the moments to share some messages with you. And the first message is a big thank you to all of my patrons who support the show financially every single month. I'm an independent podcaster. I don't have any big company paying the Pale Blue Pod bills. So your support means everything to me. Thank you so much. And I want to give a big thank you and a special shout out to my sun-like stars, Scott Reynolds, Tom T, Nicole Bartlett, Ashley Shambo, and Mark Mahoney is visible in the sky again. You know, sometimes stars eat one of their planets and then belch out a big cloud that blocks them from our view. So I hope that planet was tasty, Mark. And thank you all, you golden friends of mine. If you want to support this indie podcast on Patreon, you get to hear your name on the show, you can make it onto my Patreon star chart, and get research notes for most episodes for $5 a month at patreon.com/palebluepod. You can also make a one-time donation as a supernova, a bright source of light in the Pale Blue Pod sky. You can do that at the PayPal link in the episode description. And of course, if you can't support the show financially right now, I understand, and you're still space. I love you. The best way to help Pale Blue Pod grow is to get more people listening to it, more people downloading, more people befriending the universe. So make Pale Blue Pod a group activity like a book club or your Love Island watch club, and I will really appreciate it. Thank you in advance. My next message is a podcast recommendation, another show in the Multitude Collective called Simple and Clean. This is a show where the hosts Misha, who edits Pale Blue Pod, and Mayana Barron, who has been on Pale Blue Pod a couple of times, and their friends talk about Kingdom Hearts, a little video game franchise about really big feelings. As a non-video game player myself, it's really nice to have such welcoming and informative people talking about this game. You can join them as they discuss the plot, the characters, the world building, the music, fashion, fan base, and societal impact of this thing that, by all means, probably shouldn't even exist. If you've never heard of Kingdom Hearts before, that's okay. I hadn't before a few months ago either. They are here to break it down for you, explain why they love it, and hopefully convince you that this weird little story deserves a place in your heart. Each week, Misha and Mayana will attempt to unravel how this deceptively expansive game series has touched an entire generation of deeply earnest weirdos, and along the way, realize that what they're talking about might not just be a video game, but a whole lot more. New episodes of Simple and Clean come out every Sunday. Listen to wherever you get your podcasts. And a personal plug of mine, if I may. That's a Lot is still going. Episodes 12 and 13 are coming out this week. This is the penultimate week of That's a Lot. So if you haven't been watching the whole show, you can catch up now. And these are a fun couple of episodes. You really see my character in the show kind of reach her breaking point. So check out That's a Lot on our YouTube, Instagram, and TikTok pages at That's a Lot Show. The links are also down in the episode description. All right, Deboki is done flipping through that book, so let's get back into this conversation about astronomy history. Okay, let's move into October.
Yes.
In 1847, on October 1st, Moiya Mitchell, have you ever heard of her?
She sounds very familiar.
She was the first professional woman astronomer in the United States.
Yes.
There's an observatory named after her, maybe up in Nantucket? Mm-hmm. I'm not sure. I don't know. But on this day in 1847, she discovered her first comet. It was its official designation is C/1847 T1 because it was a comet found in 1847, and it was the first one she found.
And because you guys have great naming conventions.
We're so good at this.
Yeah. We would have called it, like, I don't know, like Pie in the Sky or something. Like,
oh, no. See, we have those cutesy names for things, but only after we, like, give it the boring numerical thing. Because it's also called Miss Mitchell's Comet, which is cute.
That is really cute. I like that.
Back in 1847, it was still exciting to find new comets. Now we know about a bunch of them. Yeah. But back in 1847, the Denmark king, King Frederick VI, offered a prize for every new comet that was discovered. Oh. So Moiya Mitchell, she discovered it on October 10th. She left a party at her family's home, and she went outside to their home estate telescope and decided to look up at the sky instead of deal with people, which is, understandable. Yeah. And she found this comet, and her dad was like, oh, wow, you need to tell everyone about it. And she was like, no, Dad, I need to be sure. So she spent the next couple of nights observing the same comet, and then her dad had to write for her to some university and announced the discovery. But she did get the prize from King Ferdinand.
Do you know how old she was?
Let's see how fast my Google wants to work. She was born in 1818, so she was like 30 almost.
That's
a young girl.
Just a baby.
She was just a baby. I'm definitely going to have to cover Moiya Mitchell in a future scientist bio episode because she's good for astronomy history.
Yep.
But the big reason I wanted to do a This Week in Astronomy History for this week was because of what happened on October 1st, 1958. Do you have any idea? Would you like to take a guess?
October 1st, 1958?
Yes.
I assume it's something related to the moon.
This was the day NASA started.
Oh, amazing.
Yeah.
Happy birthday, NASA.
Happy birthday. You and NASA have such close birthdays.
I know.
So NASA was born out of NACA, the National Advisory Committee for Aeronautics, which was founded in 1915. And in April of 1958, after Sputnik launched, which we're going to talk about later in this episode, after Sputnik launched, President Eisenhower mandated that there would be a NACA-based civilian agency called NASA, the National Aeronautics and Space Agency, to open up later that year. He picked T. Keith Glennon, I think Thomas Keith Glennon, to be the first administrator of NASA, and an engineer named William Dana was the first NASA employee to report to work. I love that we have that little factoid. Yeah. He was reporting to a space flight center.
Do you think he had the first name badge?
Oh, I hope so. I mean, it probably went to that Glennon guy, but he got the first stamp on the punch card.
Oh my God.
When they opened in 1958, NASA had 5 different sites: the Lewis Research Center in Ohio, the Langley Research Center, and the Wallops Rocket Test Range, both in Virginia, and then the Ames Research Center and the Muroc aircraft test range, both in California. And I believe William Dana was reporting to the aircraft test range where he was testing some flight stuff.
Wowie.
And on that day, an executive order, or like some order by President Eisenhower, went into effect. He signed over all of the space projects that the U.S. was working on to be under NASA's purview. He assigned over all of the federal employees who were working on space projects. That was more than 8,000 federal employees who then became NASA employees. And he gave them a budget of $340 million, which adjusted for inflation is about $4 billion.
Wowie.
NASA's annual budget is now about $22 to $25 billion because NASA does so much more now than they did back then.
Right.
But yeah, that was the founding of NASA.
That's so cool.
Yeah, you can't do astronomy in the U.S. without NASA, so you got to talk about it.
I know. And so, I mean, we're living, I think, through a time where I think we're grappling with the administrative purpose of government and what it means for like a lot of government to actually be about like figuring out how to spend money and how to organize people. And so in a time where it feels like it's a lot about destroying these institutions, I really like remembering like when it was also about building them and like starting them. And like it's cool now, like there's a part of me that's like NASA's always existed, which of course I know it's not true, but you're just like, you grow up, you know about NASA. It's like, right, someone had to start NASA. Someone had to be the first employee of NASA. Someone had to have that first punch card, the first badge. Like, that's really cool. Like, people did that. And I hope they can keep doing that.
Yeah, it makes it more human. Yeah, because it's so easy to think of NASA as this big agency that is divorced from people, because it's a big bureaucracy. It focuses on space. Like, it's hard to sometimes see how it connects to the human element. But when we hear stories like this of like, you know, individual people who were the first to do something like that, that brings it home.
Right. Yeah, there was a start.
Yeah. A couple years later, in 1962, on October 1st, the 300-foot Green Bank telescope was installed at the National Radio Astronomy Observatory's would-be National Radio Quiet Zone. Have you heard of the NRQZ?
No.
Oh, Deboki. Oh, Deboki.
I'm so
this
excited.
is one of my favorite
I'm so
things.
excited.
I love the National Radio Quiet Zone. It was established the next month, actually, in November of 1962. And it is this huge space straddling Virginia and West Virginia where there are restrictions on how much radio signal you can emit. It gets more and more restricted the closer to the center you get. So when you get to the observatory at the center, you aren't allowed to use Wi-Fi. You have to use cars that have I want to say like diesel spark plugs or something. Something about regular cars, the spark plugs in them, they give off radio emission. So if you're driving around the observatory, it would be picked up by telescopes.
Wow.
Any sort of microwave or something has to be put in a Faraday cage. Truly so limited. And there are people who live in the National Radio Quiet Zone, but in the less restricted areas. But yes, I love the NRQZ. And on this day in 1962, before the NRQZ even existed, a 300-foot telescope, like it saw its first light at NRAO. It was an aluminum mesh-colored dish on top of steel like trussel work. Really just looked like a giant spider constructed a web out of steel, and then you put a satellite dish on top of it. And it could move north and south, but not really east to west. That way it would just follow the motion of the Earth. And it was really instrumental in observing supernova remnants. We learned that pulsars are the remnants of supernova explosions thanks to the 300-foot telescope. And we were able to study hydrogen in clusters of galaxies that helped us confirm the existence of dark matter.
Oh, my God.
It was updated in 1970, so 8 years after it was built, and then it collapsed in 1988 because it was really heavy and had trouble supporting its weight.
Oh, no.
And with warping from snow and just temperature changes, it was in bad shape. So it fully collapsed.
Oh my God. Was it like a shock when it collapsed?
Yeah.
Like it just happened. It wasn't like we're expecting this to happen any day now kind of thing.
They might have been expecting it. Like, they could tell it was in bad repair, but it wasn't like a planned demolition.
Right. Oh, man. Yeah. That would be a lot to see happening.
And it's huge. It's like basically a football field across, but it did pave the way for my favorite ground-based telescope, the 100-meter Green Bank telescope. Went online in 2000, and it was the first telescope that I ever visited. I went to the NRQZ in high school, actually, with my chemistry class. It was like the only cool thing I did in high school. And that was just like a life-changing experience.
Is that why it's your favorite, or is there more to it?
Yeah, I think so. I mean, I love radio astronomy. I think the way that it lets you see into the gas clouds in the universe is really beautiful. But my first internship was at NRAO studying infrared. So, not radio, but like I just love that observatory.
Yeah, that's really cool.
And then October 2nd, a quiet day. There were some birthdays, but like nothing that special. Yeah. So we're going to skip on to October 3rd, Mean Girls Day.
Maybe this year something will happen on October 2nd.
Maybe. We'll see. Fingers crossed. Fingers crossed for something good.
Yep.
But on Mean Girls Day in 1935, the Hayden Planetarium opened to the public for the first time in New York City. At the time, it was America's fourth planetarium, and it was modeled after the Adler Planetarium in Chicago, which is still operating. I have friends who work there. The funds were donated by Charles Hayden.
I love planetariums. Like, I just remember going to the planetarium as a kid, and you just be like, oh, that's so cool. Especially when you're talking about, like, how exact they are with them. It's like, they didn't have to do that. Like, if I went to a planetarium and, like, you made it wrong, like, I wouldn't know. Like, you could tell me anything. I'd be like, yeah, that sounds great. So
you're
just
so
like,
right.
It's just that commitment to detail. I really love that.
Oh, I miss craftsmanship.
Yeah.
Moving on to the next day, October 4th. This is a big day. This is a huge day in astronomy history. On October 4th, 1957, the USSR launched Sputnik into space and officially started the space race.
Oh, man.
So if you do that math out, NASA started almost exactly 1 year after Sputnik launched.
What a week.
That year was wild. To be a fly in those rooms where they were discussing these things, because they really had to kick themselves into gear. People had been thinking about launching stuff into space for a long time, but like they had been actively working on it for most of the 50s. And then the USSR, like, they took off first. Sputnik was this metal ball about 22 inches across. The whole thing was about 184 pounds, and it didn't stay in space very long. It re-entered the orbit only 3 months later. So in January, it was back. But it made such a splash. I think at first, people weren't really sure what it was doing. It was actually just emitting continuous radio waves, sending them through the atmosphere so that scientists on the ground could measure how those waves were morphed by the atmosphere, which just helped us study it.
Yeah.
But it still freaked people out. And I mean, obviously, space advancement would have happened. But I wonder if it hadn't been the USSR who launched Sputnik, and if there hadn't been that political tension.
Right.
I wonder how different the astronomy industry would be today.
Yeah.
Like if India had launched it?
Yeah.
Or the UK? Yeah.
Yeah. And that's such an interesting thing to think about in so many directions. Like, you could write such a fascinating alternate history book about this, because it's both where would the astronomy industry be, but where would culture be? Like, who would be our icons? Like, we have all these astronauts who were so iconic of that age in a way that I don't think astronauts these days are iconic in the same way. Scientists certainly are not as iconic in that way. That's a really rare kind of moment to have happen in that way. And that's just, again, one really specific thing. There's so many directions of how we think about space, the way it's tied in the US to a certain sense of national identity, the space race and everything was what would have been the national identity without that, for better or for worse. That's so fascinating.
I think we might not have Star Trek. without Sputnik.
I think you might be right. I mean, I don't know enough about like the history of sci-fi, but it seems easy to like draw a line between like Sputnik, space race, and like that particular like type of sci-fi. Like that would be a thing we'd be kind of conceiving of it as like, I don't know, just the way the universe could go.
Yeah. So like culture, science, like politics. Ugh.
Yeah.
A fun world building exercise. There's a movie, I think, For All Mankind. Like there's a TV show where they imagine the alternate where the Russians got to the moon first, I think.
Oh, right.
Yeah. What a time.
Yeah.
Okay. We're at October 5th. Yes. which is why I extended it to the Sunday. On October 5th in 1582, we officially switched over from the Julian calendar to the Gregorian calendar.
Oh, man, time. We switched time.
We switched time. We changed time.
Yeah.
Yes. I did a whole calendar episode. It was episode 66. So you can go back and learn more about like leap years and everything. But for this week in history, back in the year 45 BCE, not on this day, Julius Caesar mandated a calendar. That calendar stayed with us for, 1,200 years. By the Middle Ages, we realized that the mistakes in that calendar, where there were 12 months and every 4 years there was a leap year, that made Easter move too far away from the spring equinox, which was unacceptable.
Yes.
Because we were like, over many centuries, just losing days. So Easter ended up being like 10 days before the equinox, which we couldn't have. So Pope Gregory XIII authorized a new calendar. He was like, hey, all of you scribes and church mathematicians, I need you to figure out a calendar system where we can have leap years, but not too many leap years. Yeah. So now we have this system where there's a leap year every 4 years, but not every 100 years.
Right.
But if that 100 year is divisible by 400, then you can have the leap year.
Okay, that explains why the year 2000 is a leap year. Because I never realized that the 100 years were not leap years, because I was like, yeah, but 2000 was a leap year. That doesn't make sense. But like that explains it.
Yes. The millennials, that being like the weird leap year that we experienced, it's going to mess us up for calculations
forever.
Of leap years to come. Yeah.
Yeah. Because I think I remember I was learning about like Y2K and like how programmers like they had to create like a set of standards for like calendar dating in computers going forward to like basically deal with Y2K and to make it so that both that it wouldn't be an issue in the moment and also it wouldn't be an issue going forward and like just make it a standardized thing in programming. And I remember reading something about the leap years and I was like one of the things they had to standardize was the leap years, which I think was probably always there. Like the real standardization was like other aspects, like making sure you did a full 4-digit year instead of just using ohhh, which would like cause problems every time there's a new century. But as part of that, like as part of the documented set of rules was a rule about like how to program leap years. And I remember being so confused by that because I was like, but 2000 was a leap year.
I know. I think of like the nested conditionals you have to do for this.
Yeah.
Yeah. So that was all thanks to Pope Gregory XIII. Thanks, Pope, the calendar Pope, I like to call him. And that was also when they decided that January 1st was going to be the start of the new year. Before that, it was around the spring equinox. So like March 24th or something would be the start of the new year.
That is wild. I cannot imagine March being the beginning of the year, but now that I say it, I'm like, there is kind of a logic to it. Like there is kind of
it's when all the things come back.
Yeah, like there is something weird about starting the year in winter, and like at least up here in the northern hemisphere, and being like, it's still this. Like you wake up January 1st, and it's still cold outside, and it's still this weather.
I agree. I think that this is one very like big misstep we took in humanity's history, because every time January 1st rolls around, I refuse to acknowledge like this is not a new year. This is still the dead of last year. I don't need to be a new person with new resolutions until spring.
Yeah, March. I mean, that's why spring cleaning is a thing. Like that's when things change. That's when things move over. Okay, I'm on board with this. This is like my new mission in life.
Thank you. Thank you. Okay, so Calendar Pope made that calendar in 1582. And after that, different countries around Europe took their sweet time adopting it. And England was especially chaotic. They were using both calendars, whichever one they wanted, until 1752. And on September 2nd, 1752, I don't know if it was the church or like the English authorities, whatever, they were like, no, everyone, we are switching over to the new calendar. September 2nd happened, and then the next day was September 14th because they had to get rid of 11 days. And they were just like, nope, those are missing. Let's get rid of them. Any sins that happen
on the New Year, we all struggle with like writing the new year. Yes. Imagine like trying to remember like yesterday was September 4th and today is September 14th. Like
I could not.
That would drive me up a wall.
It actually did have a lot of like weird consequences too. Like there were these dates that suddenly went missing, and can things be official on dates that don't exist? And
like historians studying that time, do they have to like remember like right September 3rd through the 13th just don't exist in England?
They must. Except it's only like in England, like everywhere else that adopted the Gregorian calendar earlier, they have September 6th.
Oh, this is so cool. This is the weirdest thing I've ever learned now. I'm going to be thinking about this all the time. I'm going to tell so many people this.
Yay!
What year was it? It was 1752?
Yeah, that's when they switched over.
Okay, so September 3rd through the 13th, 1752 does not exist in England. Mm-hmm. Amazing.
Oh, that would be a fun, like, trivia question. Be like, true or false?
Absolutely.
On September 6th, 1752 in England, this happened. And you're like, no. That's not a real date.
Can't happen.
Love it. So that's why I had to include October 5th. And then I saw that another amazing thing happened on October 5th. In 1923, Dr. Edwin Hubble, considered by many to be the father of extragalactic astronomy, discovered the first Cepheid variable in the Andromeda galaxy. And he measured its distance using Henrietta Leavitt's law, where she had found a few years earlier that if you measure the period of this particular star, it like pulses in brightness, and it has a very regular period. The longer the period is, the brighter that star is. So if you measure its period, you can measure how bright it intrinsically is. And if you know how bright it looks to you, you can measure how far away it is, because we know how the appearance of light falls off with distance.
Wow.
So he measured the distance to Andromeda, and he was like, oh, that is really, really far away. That's bigger than any measurement we have for the size of the Milky Way. And he settled what astronomers call the Great Debate, which was happening in the early 1920s. Astronomers weren't sure if there was one galaxy or if there were many. They called them little island universes. And Hubble was able to settle that debate with this one discovery. Now we know that there are hundreds of billions of galaxies out in the universe.
Wow. Yeah, imagine realizing that for the first time, that there really are other galaxies.
Yeah, really opened our eyes.
Yeah. I wonder like what his thought process was like with like that realization, like of like, I guess it's hard for me to imagine, because it's like the people studying this have been considering it. Like they have been in the place. And again, like kind of going back to earlier, we were talking about speed of light. Like people have been considering it. So it's not like it was this thing that came out of nowhere that was like, actually, oh my God, like there's a finite speed to light, or there are other galaxies. But what does it feel like to like confirm something like that? I just can't imagine.
Well, I mean, in your research, do you remember any moments where you like made a discovery, and for that like brief second before you told your advisor, you were the only person in the world to know it?
Yes and no, because so I was working in engineering, and I was really working on like designs that we wanted to make work. So I don't know that for my work there was a lot of things that I was necessarily like discovering, but there was like something that I was troubleshooting, and I like realized it. It was like a big thing for me to like realize. It was like the thing that made it so that I could actually finish this project and graduate, because like this project was like not working. And so I think there was a moment for me there where it's not like an exciting like discovery in terms of like advancing science, but it was something that like in the context of my conversations with my advisor about my work, that it was like, I know this, you don't know it yet, I'm going to show it to you, and this is going to like change everything, and I'm excited about that.
Yeah. I imagine they felt pretty similarly.
Yeah. Have you had moments like that with your work?
Yeah, that was one of my favorite. I know now that research really isn't for me. It's a tedious process
that feeling.
I'm not well suited for it. But the times when I loved it were those moments where like I would just like sit in my chair for a little bit and revel in it. And then I would go and tell my advisor.
Yeah, that is really cool. Yeah, I think that's a little bit of a difference. I mean, this is not universally true for engineering research because I think there is a lot of engineering research that is about like discovery. It's just the type of research I was doing in grad school was less like that. But then, you know, when I think about my undergrad research, it was a little bit more like that. Like it was cool to like kind of have those results and be like, and like I was working on different projects, like kind of computational modeling projects where, it was a little more like we're looking for something. We're like kind of like digging into this to see what we can find. So you have that feeling of like, I think I found something. Like I think I found a pattern that like nobody knew about before. That's really cool. And like even like related to that, even with engineering, like I'm the world's foremost expert on recombinase-based genetic circuits for control of chimeric antigen receptor therapies in T cells. Like I am that expert.
Yes, you are. You go, girl, go off.
So like when I think back to like that switch I made from research to writing, like I'm like, you know, I got something really cool. I got something really like niche and unique, and I'm really proud of it. And then I took it in a different direction.
Yay. Oh, yes. We both went over to the writer side.
Yes, we sure did.
That pun works better when you see it written out.
Yeah. No, I heard it. I felt it.
Thanks. Thank you. Thank you. So that was this week in astronomy history. Deboki, I'm wondering if you have any predictions for this week in astronomy future.
Ooh. Not just like this year, like just like in general, things that could happen.
In general. You could be like, I predict that in 1,522 years, like this star will go supernova. Or like, I predict next year we're going to find aliens. Like that's the range.
Yeah. Okay. I would like to say in 2,000 years, we will have sent people to another galaxy.
Ooh, I like that prediction. I'm going to be monitoring, and 2,000 years from now, I'll let you know if you were right. I'll send you a postcard.
Thank you.
From the other galaxy.
Yes.
Oh, I love that. I predict that in 587 years, we will make contact with aliens from our solar system.
Like the aliens are in our solar system and we're going to find them. And we're going to be talking to them.
Yeah.
I love that. Yeah, I think that's going to happen in exactly 587 years. What do you think our first message will be?
What's up? I think the aliens will be really into late 90s, early 2000s culture.
Yeah. This specific era will really call to them. Yeah.
That's what light waves have reached them.
Yep. I agree.
Thank you. This has been so much fun. Do you have any lingering questions or thoughts?
No, I mean, this was a lot of fun. I learned so much. This was a big week in astronomy history. So thank you for taking me along for the journey.
Thanks for joining. I would love for you to share any links, any sites that you want to. Please brag about yourself and tell us where we can find you online.
Yeah, check out Tiny Matters podcast. Wherever you listen to this podcast, you'll also be able to find Tiny Matters. Me and my co-host, Sam Jones, we talk about a lot of different things. We did an episode recently about astrobiology, which was a lot of fun. Coming at this as like not an astrobiology person or a space person. It was really cool to learn. We had another one recently about the evolution of cats, which is really cool to learn about too, because cats are wild. Mine is somewhere in this room right now, and he is just like, yep, we are. So yeah, check out Tiny Matters. And then if you want to see more of my work, I have been trying to keep my site a little bit more updated. You can go to debokic.com, DEBOKIC, and yeah, find out what I've been working on.
Yay, that's awesome. Those links are down in the show notes, so listeners, check them out. Check out Tiny Matters. I'm a fan. It is so nice to have a science podcast that's like about all of the disciplines.
Yeah, thanks.
Yeah.
It's a lot of fun for us because Sam and I are both biology people. So like we have a tendency to like be like, oh, right, biology is so cool. But then we do these other episodes and we're like, everything else is so cool too.
Yes, it is. I always said like astronomy to me is not the most inherently interesting science. It's just the one that I had the first good experience with. So.
Yeah, that's a really interesting way of putting it.
All right. Well, listeners, no matter what science you first had a good experience with, you are space. Remember that. Pale Blue Pod is hosted by me, Dr. Moiya McTier, aka the universe's bestie. I created the show with original co-host Corinne Caputo, a comedienne extraordinaire, and help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen, and our audio editing is handled by the incomparable Misha Stanton. I am Go Astro Mo everywhere online, and you can stay in touch with the show and the universe by following Pale Blue Pod on Instagram or checking out our website, palebluepod.com. We are a member of Multitude, an independent podcast collective and production studio. So if you like Pale Blue Pod, you will love the other shows that live at multitude.productions. And if you want a shout out on the show and research notes for every episode, you can join our community over at patreon.com/palebluepod for just about $1 per episode. Thank you so much for listening to Pale Blue Pod. I'll be back next week. Bye.